The logistic regression is used when the dependent variable is categorical. So in the previous linear regression, we make a relationship between the input and the output. Here, within the input itself, we make so many categories and we go for finding the relationship between this. So in that predictions, we we can able to find the result as, we can set the result as yes or no or 0 or 1. This models the probability that given the input belongs to a certain class of logistic or sigmoid function. So for finding out this relationship, we use a special function called sigmoid functions. We'll see in the later slide. So this is called a sigmoid function. How the sigmoid function is defined. So in the sigmoid function, the output y, I can write it as b naught, beta naught plus beta 1 x1 plus beta 2 x2 plus beta and so on up to beta n into xn. So why we know that it's an input, where x1 and x, I told that here we are going to have so many classification with the input variables, or we can call it as independent variables. We never bother about the output variable, but we are finding out the relationship only with the so many classification of independent variables. So now here beta 1, beta 2, beta up to beta n is nothing but the coefficient of the linear regression model, where x1, x2 are not are number of input variables, what we are going to say it. So now the sigmoid function, we call that sigmoid value is going to be y, and it converts into the probability value between 0 and 1. The formula for the sigmoid function is sigmoid v is equal to 1 divided by 1 plus e to the power of minus v. The sigmoid is, this is how we explain this, what we call it as 1 divided by 1 plus e to the power of minus y. Y is nothing but the output we derived. So this is the how the sigmoid function is. See, we are going to relate with the input variable. So I told that y is the output, and we are going to relate with the relationship called beta 1, beta 2 with this corresponding input variables. We are going to find out how x1 have this independent variable. We call it as a x1. How the x1 is having an effect on y, how x2 is going to affect the y, how x3 is going to have an changes in the y. Like that, each and every variables of the input have variations, will produce some variations on y. So each and every variable has some effect on the output values. That is called the y, how they have defined the y. So now we'll take some example to represent the logistic regression. So the use cases, we are going to take the student pass. Based on the marks, we can predict whether he has passed or failed, how many numbers of hours he has used for getting a pass. So if x is the number of hours he studied, that is the input if you are going to take it, and we are going to say the y is the pass mark. So now my pass will be equivalent to y 1 divided by 1 plus e to the power of minus a plus bx. Already we told that y is equal to, in linear regression, we told that y is equal to mx plus c. Same thing here, they are using it. This gives a probability of passing, which can be the threshold at a value of 0.05 to classify it. So for passing it, he should have a minimum pass value to be, for example, if it is for 50, if he has taken, means he will be passed. More than 50, it is known that he is passed. If he scored less than 50, he has been declared as fail marks. So this is how we make a notes. So this is the prediction we are going to do it. So we created a table. Study hours is 1, 2, 3, 4, 5, totally 5 hours for minimum 1 hour, maximum 5 hours. A number of how many notes he has used, and we are going to predict whether he is pass or fail. So if he has used one hour for studying and 0 notes, blindly is you uses some thing materials, not even the materials, some online things, and then we use it, he'll be fail. The scored marks will be less than 50. If you use 2 hours and not even using a notes, means, and simply is using some other communication things for studying, if you use some internet or whatever may be it, and in that case, if he scored less marks, then he is failed. So more than 3 hours, 4, 5 hours, suppose if they have used the notes, then we declare that person who has scored, given the output to be more than 50, means we will be declaring it as pass mark. So on this criteria, we are going to create an what chart. We are going to create a plot, used number of nodes versus the study hours. So they says that, so we can see that one and red colored dots represents the pain and the green colored dots represents the pass. This is the graph between study hours and versus nodes. Now we are going to use a logistic regression process to predict the pass mark. To predict the pass mark. So using the sigmoid function, we are going to we are going to draw the line, and that line where how many points are coming on that line. So we are going to make that the year. So already we told that using the sigmoid function, you are going to scale down the values between 0 to 1, between 0 to 1. If e reaches to nearly equal to 1, then we declare that student is getting a pass mark. If e is going to get a value below nearly to 0, means we are going to declare that student to be a fail mark. So he is being failed. So we are adjusting using the sigmoid function. We are making the above graph, and we are drawing a line such a way that y is equal to mx plus c, same linear line we are going to draw it. So when we draw a line, we want to pick those pass mark to lie on that line. So for that, we are adjusting using a sigmoid function so that the values are lying between 0 to 1, and we based on that value we are going to predict that the student has passed or failed. So this is how we have done it. We can see that how close up the points are coming to the linear line. So this is the logistic regression, hours versus probability of passing with the help of an sigma. You can see the sigmoid graph is going to be some S curve we are getting it. We are seeing that by adjusting previous thing, previous slide, we have made an we have shown what the values, how the values have been predicted, how what adjustment we are doing it. When I use a sigmoid function, how the values have been adjusted. You can see that how the values threshold point we are achieving it, and this is a threshold point we are fixing it to be 0.5, and actual data points which lies on this curve. This is called logistic regression function with the help of sigmoid value. So application of logistic regression is medical diagnosis we can deploy, whether the disease is present or not, and the credit scoring, whether the loan is approved or not, marketing, whether the customer will buy the product or not, email, whether it is spam email or not. Like that, we can go for all this kind of predictions. Here in the case of logistic regressions, the output probabilities will lie between 0 to 1. Already I told that. And it is used for binary predictions, binary categorical outcomes only we predicted. So here they uses a function called sigmoid function. Here the classification which has been used here is going to be not a continuous prediction, whereas there is a where in the case of linear we go monitor for continuous things. So in this case, what we are going to do with the logistic regression will work for the complex variables. Will work for complex variables. I think we have discussed about deeply the